Okay, so we're going to move on to Chapter 5. It's called, Chapter 5 is Project Scheduling Models. So, how many people have led a project at work? Okay, anyone a project manager by trade? Is that their title? Okay, project management is about getting things done. So it's the most, I think, primal of all business studies, because for years and years we've been getting things done, right? Well, there's a whole field of study about managing projects. Projects, as you know, are temporary endeavors. Temporary meaning can be a week, can be a year, could be 10 years, could be 20 years, okay? A temporary endeavor undertaking to accomplish some goal, to create a product, to create a service, to create some product, some deliverable. Very common for people that work in like the IT industry. You're an age of change, so your life moves from project to project. A consulting agency, some of you are always working with projects. Now, what's nice about project management is it kind of pulls across a lot of different business disciplines. It pulls across risk and quality and human resource management and communications management. And there is an organization that is dedicated to the study of project management called PMI, which stands for the Project Management Institute. You guys ever hear of the Project Management Institute? Yes? No? Yes? Maybe? Well, Project Management Institute, they publish something known as the PMBOK, okay, which stands for the Project Management Body of Knowledge. And I think that's a great term for anything, body of knowledge. Project Management Body of Knowledge. And it's in the 5th edition. And it is the ANSI standard for project management processes. Okay? So you guys heard of ANSI, the American national standard. They're the people that say a pound is a pound. So this is what they say how you should run a good project, okay, according to this PMBOK. And there's stakeholder management, communications management, time management, cost management. There's different what they call knowledge areas. They have a certificate or a certification that you can achieve. It's called the PMP. You guys ever hear of the PMP? It stands for Project Management Professional. I am a PMP, which is an unfortunate acronym because when you try to say it, it's not really something you want to put after your name when you're a professor, but I am proudly a PMP, okay? It requires you to have so much experience in project management. You also have to go through some education. College education counts. This little module we're doing on project management can count toward that education requirement. And you have to pass an exam. Okay, so it's a certification. There's also a certification that's put out by CompTIA. Has anyone ever heard of CompTIA? They put out like certifications like A+, Office Plus. They're like different certifications. And they have one called Project Plus, and I got that one as well. Okay, so project management is something that is very near and dear to my heart. I actually own a company called the Project Management Training Group. I laugh because it's called the Project Management Training Group, but it's this guy only. Because I've done some training initiatives on project management, which are much more lucrative than teaching an MBA class. But I digress. That is what project management, is all about. Now, what we're going to specifically look at in this class is we're going to talk about scheduling, which is one component of project management. But there are very, very good models to do that. And we're also going to talk a little bit about cost and budgeting as well. But project scheduling models is what we're going to focus on, okay? So some of the things that we want to define to start with, okay? A project is a collection of tasks that must be completed in minimal time at minimal cost, right? We've heard those things before. Optimization, we're trying to get this done as soon as possible. We're trying to get it done as quickly as possible. Objectives of project scheduling, completing the project as early as possible by determining the early start and early finish of each activity. We'll do that in a second. We're going to look at a little bit of probability, because you think about it, if I ask you, how long is it going to take you to drive home tonight? Kent, how long is it going to take you to drive home tonight? 30 minutes. Is it exactly 35 minutes? Do you drive home exactly 35 minutes every day? No, it really follows the probability distribution. That may be your average time, right? That might be your mean, 35 minutes, yes. But there's times where it might take you 42 minutes. There's times when it, 28 minutes, right? So a lot of times projects are that way as well. We're not going to say, hey, we guarantee you this project's going to be done October 15th or October 17th. Okay? A lot of times we say, hey, there's a 90% chance it's going to be done by November 3rd. Okay, so we're going to look at the likelihood of that as well. And we're going to use some techniques for that. Sometimes we want to find the minimum cost schedule. We're going to talk as well about crashing projects, which is a schedule compression technique. And what our objectives of this is we want to investigate results of possible delays in activities or tasks that comprise schedules. We want to see where we're at, progress control. We're not going to do much of that. We can talk about smoothing out resources. We're not going to do much of that in this course either, but that is something done with project schedule. So some other things, some other terms. Okay? And in this class, we're just going to use the terms task and activities interchangeably. Just think of a task as a body of work that needs to be completed, a unit of work that needs to be completed. Making a pizza is a project. There are various tasks that are completed. Preheat the oven, roll out the dough, put on the sauce, put on the cheese, all those good things. Right? Can't make a pizza, but I'm imagining the steps involved. Okay? Activity completion time is related to the amount of resources committed to it. The degree of activity details depends on the application and the specificity of the data. Okay. So here's what we're doing. And once again, you see this word optimal. Okay? Optimal is what we were doing in the first part of the class, right? Optimization, taking the best way. So what we're going to try to do is determine optimal schedules. Okay, that's what we're going to do. Now, one thing I forgot to mention is there are three things that are concerned with a project, okay? And we're going to focus on this one on one of them. It's called the iron triangle of project management, because these three things, if you change one of them, it impacts the other. And one is time. Makes sense, right? What else do we need to consider when we think about a project? Besides time, what else do we consider? I mentioned one already. Costs, right, costs. And the other one, this is also sometimes called the scope triangle. Okay, scope is, what's the scope of the project? Are you building a shed? Are you building 10 sheds? Are you building a mansion, right? How big is the project? And the reason this is called the iron triangle, or sometimes called the scope triangle, is if you think about it, if I increase scope, what's going to happen with time and cost? It's going to take longer, it's going to cost more, right? If I decrease the budget, what's going to happen likely? I'm probably going to have to reduce the scope, right? They're all related. Yes, if I decrease the time, well, it's either going to cost me more money because it's a rush job, right? And I need more resources, or I'm going to have to lose scope. Okay, so it's called the iron triangle because changing one inevitably affects the other. Now, what we're going to focus on when we talk about schedule is we're focusing on the time component. Okay, just the time component of this. We'll talk a little bit about cost, not so much in this class about scope. And truthfully, when I used to work for M&T Bank, and I was a project manager for M&T Bank, and we do projects, internal projects for commercial lending or whatever, various business units, finance. And we used to make people rank these three things, like what's most important in this project for you? Time, cost, or scope. And what did people do? What do people want? They want everything, right? Because you made them force, you said, well, you need to rank these things. And if they rank time first, we said, okay, we'll definitely meet that deadline, but it may cost you more money, and we may have to reduce scope. And if they said cost was number one, we said, okay, we'll stay under this cost. That was like the subject to part, right? That's their maximized, but it may cost you scope and it may cost you time. And if they said scope was their number one, we need all these features and functions in this thing. Well, hey, that might cost you more money and it might take longer than expected. We only guaranteed them one thing that we adhered to. Think about in an optimization model, that's the constraint part, right? The other two we try to optimize, but the constraint was the only thing we can guarantee. It was an awful thing because people didn't understand, right? They just said, what are you doing? I want something that's done well, I want something done fast, and I want everything I want, right? So it was always an awkward conversation. That was how we were supposed to be. All right, so what do we need to do this schedule component? Well, a couple things. The first thing we need to do is identify all the activities of a project. Okay? All the activities of a project. So when I talked about the pizza, we need to roll out the dough, we need to preheat the oven, we need to put on the cheese, we need to slice it, we need to put on sauce. Now I gave those things to you. Those are identifying all the activities, and that's a step in the process. I didn't give them to you in order because the second thing we need to do is put them in order, right? Identify all the relationships among the activities. I didn't give them to you in order, but we know the order of that. We know you roll out the dough, you have to do that before you put on the sauce. You have to put on the sauce before you put on the cheese, right? You have to preheat the oven at some point before you put it in the oven, right? So we need to not only know all the project activities, but we need to determine the relationship among the activities. Once we have that, once we have that, we can also estimate the duration of those activities, and that's the tool I'm going to show you next. Based on this information, we can develop some managerial tools for this project. So all I want you to do is, and this is in your book, but all I want you to do is kind of follow along here, and then we'll do an example. I'll have you do an example, and we'll come back together and do it. So Clone Computers wants to make a new product, okay? Manufacture a new computer, train the staff, advertise a new computer. So they come up with this. Okay, they come up with these activities, and obviously, in a real project, you sometimes have hundreds or maybe thousands of activities. Does anyone ever use project management software like Microsoft Project or Artemis? Okay. Well, anyways, one of the first things you do is try to figure out all the activities. So we're just going to call these, and a lot of times they do that. We're going to give this first one activity A, which is prototype model design. Activity B is purchase of materials. C is manufacture a prototype model. You get the picture. So we only have 10 activities. The second thing I need to do is determine the relationship. Now there's all types, if you study project management, there's all types of relationships. There's relationships where you say, hey, these two things, this one can't start until this one finishes. They have to start at the same time. This one has to start while this one is in duration. We're not going to get into this in the scope of that this course. We're only going to talk about finish to start kind of relationships, which mean, for example, activity A waits on nothing. Okay? Its predecessor is nothing. It is the kickoff activity. It can start right away. It's going to take 90 days, let's say 90 days, whatever the hell that is. Activity B waits until A is complete. It's going to take 15 days. Activity C waits on B, it takes 5 days. G, for example, needs C and F to complete before it starts, and it's going to take 14 days. So someone has come up with this. They've said, here are the activities that this project is comprised of. Here is how long we think each of these activities will take. And here is the relationship among these. The question I have for you is, when can this project be done the soonest? When's the earliest this project can be done? How would you go about figuring that out? We're going to do it in a second, but how would you go about doing it? What's the earliest this project can be done? What's that? Well, 90 days is just activity A is done, but we can even start B, right? B has to wait until A is done. So that's 105 days, right? Activity C was on B, that's another 5 days. But some of these things are done in concert with one another. If I wanted to try to visualize how these things take place, how would you draw it? How would you kind of draw it? We use these kind of models already in chapter 4. How would you draw it? Okay, you might draw it as a network, okay? And the network might look like, I'm going to go back, but the network might look something like this. if you remember, activity A had no predecessor, right? Nothing waited on activity A. It could happen right away. B waited on A. C waited on B. If you remember G, remember I pointed out G waited on both C and A, right? So here is what it looks like visually, right? And I can kind of say this is time, and this is when my project's done. When E, H, and J are done. They have no successors, if you will. They're the end of the project, have a party, we're all done, right? So how do I figure out when this project is done, the earliest? How would you do this? How would you go about it? Any thoughts? Go ahead, Tyler, you're right. Okay, so you're going to add up A, F, G, D, and H? Okay. In this case, you'd be a little bit off, I believe. I think you'd be off. That's a good thing. What you're saying is, what are you trying to find, Tyler? I like what you're thinking. What are you trying to find? The endpoint, and you're trying to find the longest path through the network, right? We're going to give that path a certain term in a minute, but we need a model, we need a method to figure out when all these activities are going to get done. So what we're going to do is before we get to when are all the activities going to be done, for each activity, we're going to define two things. We're going to define an early start time and an early finish time for each activity. When's the earliest this activity can start, and when's the earliest this activity can finish. So we're going to not just do it for the whole project, and Tyler had the right idea, but we're going to do it for each activity. We call those two things the early start time and the late, the early start time and the early finish time. Okay, that's the first thing. We want the early start time and the early finish time. Now, this is the methodology we're going to go through. But we'll come back to this slide, just do it ourselves, okay? And then we'll come back and look at what it says. So we start with the nodes that have no immediate predecessors. In this case, there's only one. So it starts on day 0, and it has a duration of 90, so it's going to be end at day 9. So the early start time of activity A is today. The early end, the early finish, is 90. And this is like the beginning of the day 90, the way it works. Okay, so this is starts now, ends beginning of the day 90. So when's the earliest B can start? 90. And the earliest it can end, remember that was 15, so 90 plus 15 is 105. This was 25, so 90 plus 25 is 115. 90 plus 30 is 120. You guys follow me? So you can keep going. This is called a forward pass. C, for example, start at 105 and end at what? 110, right? 105, 110. Now, we have an issue. We have a convergence. G needs C to finish and F to finish before it can start. It needs both to be done before it can start. So according to this, when's the earliest G can start? Right. We take the max of the early finish of the preceding node. In this case, the max of the two is 115. So 115 plus 14 is 129. I'm going to keep going through with this. D now, or J waits on D and I. So when is the earliest J can start? 120, 149. The earliest it can start is 149. So keep adding duration. So Tyler, when is this project, how many days until this project is completely done? What was that? 194, exactly. So everything is done in this project is 194. Now, that's the first thing. We're going to calculate the early start, early finish time for each activity. That's the earliest the activity can start, earliest it can finish. Now that is useful in itself because now it tells us, hey, the earliest this whole damn thing can be done is 194 days. but it's not the end. What we also want is we realize a couple of things. No matter how fast we go, when's the earliest J is going to be done? Okay? But H can be done at 177, E can be done at 170. So that leads me to believe that these have some wiggle room, right? Like we can maybe delay this one a little bit. Maybe we could delay because, hey, everything's not going to be done until day 194 anyways. So what if we could delay that? I mean, we can. So we're going to calculate out not just the early start, early finish for each node, but we're going to figure out something called the late start and late finish for each node. Okay? Late start and late finish for each node is when's the latest this activity can start and the latest it can finish without impacting that 194. Okay? Without impacting that 194 completion time. When's the latest each activity can start, when's the latest it can finish without impacting that node. Okay, so this is the methodology. We'll come back to the methodology, but we can probably just reason this out. So first things first. The earliest the project can be done is 194. So we know, hey, this could be done at 170 in an earliest situation. This could be done at 177 in an early situation. But you know what? This could also start or finish as late as 194 and not impact the overall project. So they all get a late finish of 194, okay? Because that's the latest they can finish without impacting the project. 194 minus the 28 duration is 166. 194 minus 21 is 173. 194 minus 45 is 149. Okay, now let's think about D. Okay, D is a predecessor to E, H, and J. The latest this can start is 149. The latest this can start is 166. The latest that can start is 173. So what's the latest D can finish without impacting any of those? What's the latest D can finish without impacting any of those? 149, because the latest this can start is 149, right? So it's going to say, it's going to get 149, 129 as well, okay? We keep making this backward pass, okay? So this one's going to be easy. This is going to be 129, 115. Let's look at I, though, okay? I'm going to move to I. I is an immediate predecessor just for J, J alone. The earliest J, or the latest J can start is 149. So when's the latest I can start without impacting J? When's the latest I can finish, without impacting J? 149. Not a word, but 149. Very good. And we just keep working our way back. Okay, working our way back to say, hey, when's the latest this can start? When's the latest this can finish? When's the latest this can start? When's the latest this can finish? Until we're at the very end, and for each activity, we have two sets of dates. We have early start, early finish, late start, late finish. Now I want you to know, some of these activities have the same early start and late start. Give me the activities that have the same early start and late start. A, right? F, G, B, and J. Okay? What that is saying is those activities have no wiggle room. If they get delayed at all, it's going to delay our project by that amount. They need to start as soon as possible because they are critical. And in fact, the activities on the network that are critical are called critical path activities. That's something you can write down. Critical path activities. They're called critical path activities because they have no wiggle room. A delay in a critical path activity will delay the project by that amount. If you use project management software like Microsoft Project, and you use a network diagram, that's what this is, it puts the critical path activities in red. Everything else is in black, and the critical path activities are in red. Why is it important to identify those? Why is it a good thing managerially to identify those? If you're a project manager, why is it a good thing to identify them? I have a red line through my network diagram? Why? If you're the project manager, these aren't saying these are the most important activities. It's not saying these are the most important activities, like the most critical, like most. It says if we delay one of these a day, it's going to delay the overall project. So if you're a project manager, you want to keep an eye on those, right? You want to watch those like a hawk, because if they fall behind, our whole project's going to fall behind. So those are called critical path activities. Every project has at least one critical path. The critical path is the longest path through the network. Okay, the longest path through the network, and it's comprised of all activities that have what we call zero slack. Now that's a new term, slack. Also we call it surplus or slack or surplus. If we look at B, B is not on the critical path. It has an early start of 90 and a late start of 95. So how much slack would you say activity B has? 5 days. You can calculate slack by either taking late finish minus early finish, or late start minus early start. It's going to give you the same thing, right? Or the same difference. So activity, let's do another one. Activity I has how much slack? 29 days. So, a couple things we know. These can be delayed 29 days without impacting my 194. These cannot be impacted at all, or they're going to impact my 194. So, if these are happening at the same time in the project, and it looks like they roughly are, if I have extra resources to apply, where, and I know there's different resources you can apply, but saying it's all the same, where would I apply the resources as a project manager? To activity F rather than activity I, right? Because I can fall behind and still not hurt my overall project completion. This is something called CPM, which stands for the critical path method. If you use any project management scheduling software, Microsoft Project, Artemis, I'm trying to think of the other ones out there, Open Workbench, Dot Project, that's a web-based one. They are going to use the critical path method. And you're going to have early start, early finish, late start, and late finish. I can still remember M&T Bank, when I worked for the bank, they bought an enterprise project management software. And it's a classic example of giving people a tool to use. It was a fantastic tool, but never training them how to use it. Because I still remember project managers saying, why the hell are there two start dates? You know, start date's a start date. They didn't understand what early start and late start was. Why is there two finish dates? You know, people didn't understand that. So they didn't understand the principles behind this, so the tool was kind of useless for that. So let's talk, I know I went through some of this, but let's look at the slides. Slack time, activity start time and completion time may be delayed by planned reasons as well as by unforeseen reasons. Things happen. Some of these days may affect the overall completion date. To learn about the effects of these days, we calculate the slack time and form the critical path. The slack time on the critical path activities is 0, right? They were 0. Slack time, as I noted earlier, is calculated by taking late start minus early start, which is the same as late finish minus early finish. This is what happens in this project. Boom, 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 boom. These are the activities with no slack, which are critical path activities. And this is the slack for the remaining activities. Okay? What is the critical path? Critical path are activities with 0 slack. Critical path is the longest path in the network. And the sum of the completion times for the activities on the critical path is the minimal completion time of the project. If we sum up think activity, well, if we go back to this one, if we sum up these activities, I think this was 90 days, plus 15, plus 25, plus 14, plus 20, plus 45. They sum to 194. This is a critical path. If you sum all their durations, it's going to sum to 194. Okay, that's what the critical path is all about. Okay? Why do we want to understand that? Well, because in a project management environment, we have a plan, we have a project plan, but oftentimes things don't go according to plan. There's delays, or sometimes we delay things on purpose to smooth out resources, to level the resources. But we need to understand the types of delays that we can encounter. So let's look at the types of delays we can encounter. Single delays are easy to think about. If I delay a critical path activity by any amount, 1 day, 2 days, 5 days, it's going to delay the project by that same amount. We delay A by 2 days, it's going to delay the overall project by 2 days. Okay, so critical activities have zero wiggle room. We delay them, the project's going to get delayed by that amount. If it's a non-critical activity, an activity with slack or surplus, whatever you want to call it, okay? If the delay is less than the slack, we're cool. We can absorb it, right? We just said that that's what that slack is all about. If it's more than the slack, for example, maybe the activity has 5 days of slack, but I need to delay it 8 days. Well, it's going to absorb 5 of those 8 days, but the remaining, the plus 3, is going to get added to the overall product. You know what I'm saying? That makes sense? So we can absorb so much, but then the rest of that delay is going to get tacked on in the end. And in essence, that project is going to, that activity is going to become critical. So single delays are pretty easy to think about, not hard to think about. The problem comes in when, or the issue comes in when we have multiple delays. We have 3 cases we're going to present. Okay, the first case is we're going to delay non-critical activities by less than their slack time, and the activities on different paths and networks. I can't remember how much slack time I had that had both of them, like 24 days. I can't remember how much E had that had both of them. If we delay both 15 days, which is less than their slack time, is it going to impact the overall project? No. And the reason it doesn't is because there's no compounding effect. There's no cumulative effect. I and E aren't in the same path. So delaying one doesn't affect the other, right? It gets absorbed here, it's fine. J is delayed, but who cares? J, J already has wiggle room. So I and E are on different paths, so we're okay. It's not going to delay the overall project. Sometimes we have non-critical activities, and by the way, what is shown here is a really poor Gantt chart. You guys have heard of a Gantt chart? Okay, named after Henri Gantt. Terrible. I think Gantt is like American butchering of the name, but they call it. Basically, all it is we have activities over here, and then usually, typically, this is months, quarters, years, whatever it might be, and the bar represents when the activity is taking place. And a lot of times you see Gantt charts that have like arrows that indicates durations, like this activity waits on this one, to show the relationships. The bars that are red mean critical path activities. Gantt charts also have milestones. They represent them as diamonds. Okay? A milestone is an event, really not an activity, but it's a milestone achieved, like testing done, moved into production. It's a milestone in the project, right? Something that matters. The second type is these two are on the same path. They're both delayed by less than their slack time. They're on the same path, right? Okay, but there's a critical path activity separated. So what do you think the result of this is? So activity B and activity H are both delayed. I'm sorry, activity B and activity E. They're on the same path. What do you think? But there are critical activities in between, actually two. You think there's an overall delay? Is there a compounding effect? Is really the question. There isn't a compounding effect because when we get to G, remember this is early start, early finish, late start, late finish of the same. So this delay was already factored in to here. Now we're back on track, right? A critical path activity has no wiggle room. So this slack was all factored in off of that. So we can absorb it here, get back on track to here, and now, there's no compounding effect. The only time we have an issue is if there are two non-critical activities that are on the same path, like B and C here, and there's no critical path activity separating them. Then there does become a domino effect, a compound effect. A delay here will also delay this one, and there is a compound effect, okay? You don't need to figure that out, but I just wanted you to understand that. Now, what I'd like you to do, I'm going to show you how to do this with Excel, which is really ugly, okay, by the way we do in this class. In practicality, what you're going to use if you do this in the industry is you're going to use project management software. You're going to use Dot Project, you're going to use Open Workbench, you're going to use Microsoft Project. We're going to use Excel Solver, which is not the best tool. It's like pounding in a nail with a wrench, okay? But it gets the job done, okay? So what I want you guys to do is I'm going to put on the board, take a break, it's 5 after 7, but I'm going to put a precedence relationship chart on the board or on the document camera. And I want you guys to make a network diagram and then figure out the early start, early finish, late start, late finish for the project. You know what I'm saying? Do that forward pass and that backward pass. Figure out that for this. And I'm going to put it on the, I think I have one here. I'll put it up on the document. So take a little break, and then we'll do that over break as well.